Hello, we are Group 28 and welcome to our video concerning the economic order quantity model. Let us explain this model by directly jumping into a practical example. This is Mario, the owner of a pretty small restaurant in Biasca, Ticino. He works with Luigi, his longtime friend and coworker. So far, Mario has simply ordered 20 kilos of lettuce per week in order to satisfy his weekly demand. But now, Mario wonders if he could save money by ordering more efficiently somehow. For that purpose, there's a model called economic order quantity, which is an important inventory management tool that provides the optimal order volume for a company. In other words, it tells you how large an amount you should order to minimize your total costs. But first, mind the fact that the model does not account for the time between an order and its reception. Here, it just happens infinitely fast. Also, it simply assumes that annual demand is constant and known. In this model, total costs are depicted as the sum of total holding cost and total ordering cost. Holding cost factors are all the expenses associated with storing the products as inventory, like the rent for storage room, refrigerating cost, the cost of damaged goods, or insurance. So, to calculate the total holding cost, we have to multiply the average inventory level by the holding cost per unit per year. Order cost factors, on the other hand, are all the expenses associated with one order, such as transportation, salaries, or administration costs. Anything that needs to be done to get the goods into our inventory. So, in order to calculate the total ordering cost, you have to multiply the total numbers of orders per year by the cost per one single order. This gives you the extended formula of total cost. By minimizing this equation, we will obtain the economic order quantity formula, which allows us to quickly calculate the optimal order quantity. Here you see the derivation of the equation, which gives us the final formula. Let's jump into a practical example and see how Mario could minimize his total costs by implementing the economic order quantity model. Mario currently orders 20 kilograms of lettuce every week because his restaurant has an annual demand of 1,040 kilograms. He would like to reduce his total cost by changing his order quantity. But first, here's the cost per order. Luigi, Mario's co-worker, takes a van to pick up the lettuce at their supplier. The gas price is around 1 franc and 50 cents. The distance between the restaurant and the supplier, back and forth, is 15 kilometers, and the gas consumption is 5.5 kilometers per liter. Multiplying this distance with the gas price per liter and dividing the result by the gas consumption, we get the gasoline cost of the van for 15 kilometers, which is 4.09 francs. Luigi's wage is also part of the cost per order. He earns 20 francs an hour, and the average speed of the van is 50 kilometers per hour. Dividing the distance of 15 kilometers by the average speed of the van, we can conclude that he needs 20 minutes, so 30% of an hour, to go from the restaurant to the supplier and back to the restaurant. His wage for this 20 minutes drive is therefore 6 francs. Thus, the cost per order is 10.09 francs. However, Mario does not only order lettuce from his supplier, but also other products. In fact, lettuce only takes 1/40th of the space in the van, so the cost per order is 0.25 francs. The holding cost for the lettuce is also to be considered. When they arrive at the restaurant, lettuce is stored in the fridge. The electricity cost for this fridge is 50 francs per week. 1 kilogram of lettuce only occupies 0.1% of the space in the fridge, so the holding cost per kilogram is 0.05 francs. Now that we have the annual demand, the cost per order, and the holding cost per kilo, we can derive a set of alternative order quantities for Mario. We can apply the calculations that we learned in the lecture to find the number of orders corresponding to each alternative order quantity, the total order cost and the total holding cost. Finally, we can compute the total cost by summing up the total order cost and the total holding cost. Here are our results. Using the total cost, we can easily find the ordering quantity that triggers the lowest cost for Mario. To confirm the final result, we can use the formula to find the optimal order quantity. The optimal order quantity we find is 102.44 kilograms of lettuce. Now let's compare what Mario currently orders, 20 kilograms of lettuce, with the optimal quantity he should order according to the model, so 102.44 kilograms. Right now, Mario orders lettuce once a week, so 52 times per year. but according to the optimal order quantity, he should order only 10 times per year in order to minimize his cost. However, this means that he would have to order only every 36 days. In reality, this does not work because lettuce only lasts between 1 and 3 weeks. So if Mario ordered lettuce only every 36 days, it would go bad before the next order, causing stock out. Also, Mario does not want to throw away any food out of principle. To sum up, we have to critically look at the optimal order quantity we got from the model because it does not match reality, even if it minimizes total cost. Even if the model is incomplete here, we can still draw a conclusion from it. Since the cost per order is higher than the holding cost per kilogram, reducing total cost is possible through a reduction in the number of orders. Consequently, it means that Mario should order lettuce less often, but in bigger quantities. Currently, he is ordering lettuce once a week. One has to consider that lettuce can last for a maximum of 3 weeks before spoiling. So, to safely avoid lettuce going bad, Mario could order lettuce every 2 weeks. His total cost would then be 7.56 francs for 40 kilograms of lettuce. But his total cost is 13.62 francs for 20 kilograms of lettuce when he orders lettuce once a week. So Mario can nearly cut his costs in half. Furthermore, the total cost of 5.12 francs using the optimal order quantity is not that much lower than 7.56 francs. To sum up, we could derive a credible solution for Mario, who wanted to reduce his total cost for lettuce, using the economic order quantity model. Taking into account that lettuce is a perishable good, he should order 40 kilograms of lettuce every 2 weeks to reduce his total cost while avoiding spoiling goods.